Okay, welcome to another Programming in ARM assembly video, and in this video I just want to make a general purpose print function. Now I've actually already done this in video 5 of the number guessing game, but I wanted to do a standalone video just on this one topic. So let's go ahead and get into it. Alright, so as always I'm starting with an empty directory except for the makefile. So let's go ahead and look at our makefile. And in here, we're just going to have a main.s file that will act as just a driver code for the actual function that we're going to create, which I'm calling print. So that's going to assemble those two files, pass in the debugger option so that if we want to look at those in the debugger, we can. Then we're going to link those, and then after linking, we're just going to delete the .o files. That way, every time I make, it will remake everything. Alright, so let's go ahead and quit out of there and check out or get started on our main.s file. So to get started here, I'm just going to include the .global directive followed by _start. That _start label is the default label that's required by the linker. You can change that if you want. You can put in the -e argument with the linker and then define a different default label, but I don't see any need to do that, so I'm not going to. So we're going to probably have a data section here because we're going to need to have some sort of initial string to pass into our print function. So after the data section, we need to have the .text directive to tell the assembler where the code itself actually starts. And it's going to start here at the start label, of course. And then we're going to have an exit section, not necessary probably to define that exit label, but I do like to have it because it makes it just clear where in the code we're leaving the program. And then to exit out for ARM assembly, we need to move into register 0 an exit code of some kind. And I'm pretty sure if you don't include this, it'll just be 0 by default, but I'm going to go ahead and include it. And then we're going to move into register 7 the immediate value 1, which is just what's required for this operating system, the kernel. And then we're going to do a service call of 0. And then finally, I'm going to end this out with the .end directive. That .end directive is not required by the linker or the assembler, but I'm going to include it anyway. All right, so let's go ahead and write that. Let's quit, and let's edit our print.s file. And here, I'm going to have the .global directive followed by print. And below the and then we're going to have the actual print label, which is where the code will go. Again, I'll need I want to have an exit section and a .end directive. And that should be good enough to be able to make sure that our makefile is set up correctly and that we can assemble and link everything without any problems. So let's go ahead and make that, and let's run it and see if we can see our exit code, and we can. All right, so that's we're off to a good start. Okay, so in order to print something, or in order to write something to the screen, we need to have loaded into register 1 the string that we're going to try to print. So in the main file, this is just kind of a wrapper file for the main function that just so I can have a way to call the function. So in here, I'm just going to include a string or multiple strings that I don't necessarily care about, but just to have something to pass into the function. So let's just call it string1, because in order to test this, I want to have multiple strings, but so for now I'll just have string1. And that's going to be type ASCII, and that's required to be type ASCII and not ASCII. And the string is just going to be, hello world. It's simple. Keep it boring for now. And then before we call the print function, we need to load into register 1 the memory address of that string, and then we're going to branch and link to the function that I'm calling print. Okay, so let's save that. Let's go back into the print file, and at the top, let's kind of define what the requirements are to use this function. So I'm going to say input, and R1 must contain the memory address of this string to be printed. And then furthermore, furthermore, the string type must be ASCII's, not ASCII. Okay, that should be good enough. And then we're not going to have any output for this print function, so we don't have to worry about that. Okay, so we're going to come into the print function here, and before we, as we iterate through the string R1, we're going to end up changing the pointer in there, and there's a couple ways we can deal with that, but I think the easiest thing to do is going to be just to make a backup copy essentially of that memory address. So I'm going to move into R3 the value that's contained in R1. That way, when it comes time to actually print that information to the screen, rather than trying to subtract backwards the number of bytes, we can just recall the memory address that we originally got. And we're also going to want to move into register 2 the immediate value 0. Register 2 needs to be the size of our message. So if we look at the system call reference, we can see that R2 needs to contain, the number of characters. So we'll initialize that to 0, and then as we go through and count out the number of characters, we'll increment that by 1 each time. All right, so we're going to go into a loop here, and what we need to do in this loop is we need to load a byte, and we'll load that byte into R0. We'll load it from R3. And then we'll advance the memory address by 1 byte. So we're going to take the first byte out of R3. So in our case, it's going to be the letter H for our hello world message. We're going to load that byte into register 0, and then we're going to advance the pointer essentially of R3 forward by 1, so that the next time we come through the loop, it'll be pointing to the letter E. But before we move down into the loop, we want to compare the byte R0 with the immediate value 0, which is the null byte. And if we have reached the null byte, then it's time to exit. So we're going to say branch if equal, and we could just go straight to the exit, but I think what I'll do is I'll branch to a section that I'm going to call, I'll call it print string, essentially. Call it print string. And then if we haven't reached the end, if we haven't reached the null byte yet, then we want to take R2 and add 1 to it. So the first time we go through our hello world message, it's the R2 is 0. We go H, that's 1. We go E, that's 2. We go L, that's 3, and so on. We're just accumulating. We're incrementing R2's value by 1 each time we go through. And then I think now, we will just unconditionally branch back to the top of the loop at this point, because our exit point is going to be when we hit that null byte. All right, so then we're going to have this print string label, and in order to print our string, we need to do everything that the system call reference tells us to do, which let me shrink this down a little bit. And for my own sake, I've put those steps here because it's easier for me to read this format than it is that format. Okay, so we need to move into register 0 a standard out, and standard out is the immediate value 1. So we'll move into register 0, and I'll call it standard out, and then I'll come up here and I'll define what I mean by standard out. When I say standard out, we're really referring to the number 1. So when you go through, when this goes through the assembler, this value will get replaced with that number. But as we're looking at our code later, it's easier for me to look at this and say, oh, standard out versus 1. And then I have to think, well, why did I put 1 in register 0 here? But if I see these words, it's just easier to understand what was going on at what we're doing. And then we need to move into register 1, the pointer to the string. And since we've looped through here, we've lost our pointer essentially. Let me think about this for 1 second. So we've actually, since we linked through the copy, we should be fine. Yeah, we've incremented the copy in R3, so that means that R1 is still pointing to the beginning. R1 is still pointing to the beginning of that string, so we don't actually have to do. It should have been an LDR instruction, not a move, but we don't actually have to do that here because here we're working with the copy of the memory address, not the original memory address. So then we need to move into register 2 the size of our message. However, that's already done because that was the whole point of this loop. The whole point of this loop was to count how many characters there were in that message. So R1 is already done. It's pointing at the beginning of the string. R2 is already done because it's we counted up the message. So the last thing is R7. So we need to move into R7 the immediate value 4, which I'll just say is right. And then we'll come up here and we'll say EQU. When we use that word right, what we really mean is the number 4. And then finally, we need to do a service call, SVC, and that service call is 0. And since I'm using that equal section up there, I'll go ahead and do one here for this. I'll do another equality for this one as well. And that service call is going to be 0. All right, and then we reach our exit point here. So since we're coming into this function and we want it to be general purpose, the first thing I want to do is push onto the stack register all the registers that we're going to touch. So we're going to be touching register 0, 1, 2, 3, and 7. So I'm actually just going to push R0 through R7 onto the stack, even though we're not touching 4, 5, and 6. So I'm just going to push R0 through R7 onto the stack plus the link register. And then when we exit, we're going to pop R0 through R7 back off the stack plus the link register. And then we're going to do a branch exchange to the memory address contained in the link register. And that should take care of everything for us. So as long as there aren't any mistakes there, and I can't promise that there aren't, we'll go ahead and write that out and quit out of here, make, and we got something messed up here. I got something messed up here. Load, oh, I see, I got a typo, and I should have recognized it because with my syntax highlighting on, I should have, since that was in green, it meant that the syntax highlighter didn't recognize that instruction. Nevertheless, we'll quit, we'll make, we do make clean, make, there we go, it made, and let's see if maybe we get lucky and it works the first time. Hello world, there it is. All right, so let's mess around for a moment with our main file just to make sure that it's working the way we want it to work. So we will say, let's add a new line in here. Let's create a couple of more strings. So let's say string 2 and string 3. So after hello world, we'll just have another message here. This is a standalone print function, or I don't know, standalone, does that even make sense? I'll just say this text is coming from the print function there. I feel better about that. And then for the third one, we'll just say goodbye world. That sounds kind of morbid. Goodbye for now. And then we'll throw another new line on there. And then all I have to do is take these lines, and I just want to do it a couple more times. So we want to load string 2 and 3. Let's write that out. Let's quit. Let's make. Clear the screen, and let's run our code. All right, so we got new line, hello world, new line. This text is coming from the print function, new line. Goodbye for now, new line, new line. So I feel pretty good about that. Seems to be working. Let me just take a quick look at the print.s code to see if there's any last little bit of cleanup I want to do in here. Input R1 must contain the memory address of the string to be printed. Furthermore, the string must be ASCII, not ASCII. That's good. And we're initializing this. That's fine. We're making a backup of the memory address for R1, and then we're using the backup as opposed to the original, so we don't have to do any restoration, so that's good. We're doing our count, and yep, I don't see any problems with this, so I'm going to call it a win. If you made it to the end of the video, thank you so much for watching, and I hope to see you in the next part.